Hello everybody, my name is Alex Heller. I'm currently a sophomore mechanical engineering student at the University of Portland. My hometown is Carlsbad, California, which is where I'm at currently due to COVID restrictions. And so what I'm going to be telling you guys about, or a little bit of teaching you guys about today, is about how different components of a system can come together to get one seamless output. And how I'm going to be doing, also, sorry, I'm going a little bit ahead of myself, but also to kind of show you guys a little bit how engineering can be pretty cool and fun, which I think it can be. And I think a good example of that is right over here. So this is a wrist-mounted flamethrower that I designed and threw together. And what I'm going to be using this for is obviously what I just told you guys about, is to show you guys about how all these different complex systems can come together for one seamless output. Okay, so I'm going to walk you through each of these different components. So first of all, it's a little bit hard to see that, sorry about that. So let's start off with the first component, which is right here at the top. So that's going to be a lighter up there. So that electric lighter or plasma lighter, whatever you want to call it, is going to be our ignition for this, which is what's going to actually ignite the gas that's being extruded out of this front nozzle here, out of this pipe assembly. And how it's triggered is right over here using this switch, which I soldered together, which is going to turn on that lighter. Okay, so that's the first component. That one's pretty simple. And let's move on to the second one, which is also decently simple. And that's the one I referenced before, which is this pipe assembly here, which is pretty simple. And obviously you can see a valve here. You can see a solenoid valve here. That one's a little bit more complicated. That just allows me, that's basically just a valve that I can trigger to open and close remotely, rather than having to actually manually turn it like that. Okay, and then obviously a nozzle up here and down here. Okay, so the next component that we're going to talk about is the electrical component, which is a little bit too complex to get into right now, just because of the video kind of quality. I guess with that white background, it's kind of hard to see. So I'll just explain simply what it does, which all it really does is when I push this button over here on the side, it is going to fire this solenoid and open it for 0.3 seconds before closing it. Which, if you're wondering why 0.3 seconds, why not just a continuous flow of gas? Well, the reason why is because you don't want blowback. So if I have this open, the gas could be igniting and falling back into this, which is going to light, the user on fire, which is, in this case, me, which obviously we don't want that to happen. So we're going to try and avoid that by using the 0.3 second interval for this solenoid. And then the final component for this is going to be this microcontroller here, which is the brains of this whole operation, which is what I was able to code in order to get that 0.3 second opening and closing time. And that's this microcontroller here, which is all put together with the electrical system. Before I demonstrate this, just to give you a better, clear example of how a system can be fluid, I want to have a little bit of a mention right here, just for a little bit, like just some features you can put onto different circuits. So I have these two lights here. So when I turn on this 20-volt battery pack over here, you'll see that green light comes on. So that green light means this thing is active. So be careful, be sure you're in a safe environment like we are. So that's the first step. So it's really indicate that things are on. So that's an important safety precaution to be taken. And then also that second bulb, you might be able to see it, is a red light, and that red light is activating when it's firing. I'm not sure if you could hear those clicks, but that's the solenoid opening and closing for 0.3 seconds. Alrighty, well now that's all out of the way. So I think it's about time that we actually give this thing a shot, and I'll show you how this thing really works by demonstrating it. So we're going to be firing this thing. So the first thing that we need to be aware of is obviously safety, especially when it comes to something as dangerous as a flamethrower. We're going to be wanting to look out for safety. So to do that, let me just set this down real quick. We're going to be using a fire-resistant glove. We're going to be using, obviously, fire extinguishers on deck at all times just to be safe. And then, obviously, I'm outside, and there's actually a pool over here just in case I ignite and I can jump in there and be safe. But obviously, I think, let's just be clear here. Don't try this at home unless you know what you're doing. And so let's load it up. So first things first, we're going to put on this fire-resistant glove, which is what I'm going to be operating this thing with. And then secondly, I'm going to load this up with this butane, which is going to be our flammable gas that we're going to be using for the flamethrower. So let me just load it real quick. 1 second. Okay, so we are all loaded and ready to go. I'm going to turn the camera. We're going to turn on that lighter, and 3, 2, 1. And there you go. That, I think those are some pretty good shots of how this thing really works. And that is the wrist-mounted flamethrower, and really showing how different systems come together. Which, in my opinion, is really my favorite part about STEM and engineering as a whole, is understanding how things work, really. I mean, just as I demonstrated to you right there, things sort of seem complex on the outside, but after you're able to dissect them for each of their different components, they can get a lot more digestible and a lot more understandable, which I really enjoy, which I'm sure a lot more people would enjoy as well. How everything works. I mean, you can really learn about everything. Well, thank you for watching. My name has been Alex Heller. I'm a mechanical engineering student. Once again, just to cover everything, mechanical engineering sophomore at the University of Portland. And one quick reminder here at the end is if any students watching have completed any side projects that you've seen on the robotics website, you can submit them on the to the email robotics@up.edu. That first R is going to be capitalized. It's a capital robotics@up.edu. Thank you for watching.